Is the 24th. So guys, I do have, if you guys want it, I have an exam review like schedule, so like our exam day schedule, so these are like at the times when we have all our exams. So I have one of those, and then also I have note cards. You can use both sides of a half sheet of paper. So you guys can pick those up if you want those today. I'll have your exam reviews tomorrow, like a packet to help you guys review for exams. So this is our last day of new notes. So reminder that we're not doing a test on this chapter 11. It's just going to show up on the exam. And not any more heavily than any other section. So it's not going to be like, I didn't test on chapter 11. So it's not going to be, you know, like half the exam is not going to be chapter 11. It'll just be a few questions, just like all the other sections. So if you guys from Friday's notes, I didn't realize I didn't upload the videos onto Schoology. They should be on there now. So those of you guys who are gone Friday, so the 11.4 and 11.5 notes should be on there now. So we're going to do, again, this is our last section. So talking about areas of regular polygons today. We will take a break outside because it's nice outside. It's a little steamy even, but humid. We'll still go out. Humid, yeah. What? Oh, you need okay. Yeah, so like just a half sheet of paper. If you don't use that one, it's fine. That's just, I put it on cardstock so it's easier to find like in your notes. So if you, yeah. Then you can write and it doesn't bleed through, you know. I hate that when I'm writing on a piece of paper and my marker like bleeds through the other side. It's the worst. Mr. Donahue did that with my grocery list this weekend, and he like flipped it over and he's like, sorry, and he had written all over it and you couldn't read my writing anymore. So at the grocery store, when we go shopping, I buy all the things on the list. He takes his own card and just goes like rogue and buys whatever he feels like. So and then we meet at the cash register and I pay for all the stuff that he bought that wasn't on the list. It's pretty much like my worst case scenario. It drives me crazy. So anyway.
Comes up with a new TV.
Yeah, well, he does want a new TV. The one in our gazebo is little, and so he wants like a giant one in there. He set up the big screen TV in the basement, like so we have a like the wall. Yeah. Okay. So guys, area of a sector. I don't think, did we do area of a sector? Yeah, we did, right? That was yesterday or last time. So area of a sector. Remember that's x over 360 times pi r squared. Now this is a multiple choice question, so this is like something you guys could see on the ACT. However, if you look at their answer, do you notice what's different about their answer compared to what we did last time? What did they do? They kept the pi, they kept the fraction, so they kept pi in there. So on something like the ACT, sometimes you'll see this. So you have to kind of look at the way they have the answer written. So essentially what they did was they did everything except pi and then just simplified it as much as they could. So kind of don't actually put pi into that until the very end. So the x is that central angle. So that's 10 over 360 because that's what a whole pi would, or a whole circle would be. Times pi, which I'll leave on the end here, r squared. And r in this case is this 3 squared. So 3 squared is going to be 9. So that'll be 9. So 10 times 9 is going to be 90. Now 90 over 360. I'm going to cancel those zeros off. 9 over 36. Divide them both by 9, so that'll be 1/4. So 1/4 pi is our letter C there. So they just do that answer a little bit differently. So don't think you did something wrong just because like if you found your decimal answer, you could just figure out all those as a decimal as well and check it. But sometimes with multiple choice problems, you have to look at the choices they give you and try to decide how to figure out your answer in the best way possible. Now this one, they tell us that we have a rectangle here. It's 56 feet is the diagonal. The angle BAC AC, I don't know why they gave us that one, is 42 degrees. What's the length of AB to the nearest tenth of a foot? Now in this case, we know both diagonals should be 56. So a rectangle, the diagonals are equal. So I'm going to draw it this way instead. If it's a rectangle, I know that's a right angle. This is 42. This is 56. I'm trying to find x there. So what I did was I drew what I have. And that's a right triangle. So those of you guys who are still struggling with that trig stuff, this is trigonometry. Because we have an angle, we have a right triangle. It's not a special right triangle, so I have to use trigonometry, where this is my hypotenuse, hypotenuse. This is my hypotenuse. The opposite side I don't know, so that means this is my adjacent. So hypotenuse over adjacent. Hypotenuse over adjacent, I want to use cosine. So this is going to be cosine of 42 degrees equals adjacent over hypotenuse. So x over 56. So to solve this, I'm going to have to multiply each side by 56. So 56 times the cosine of 42 should give me that side length, and then you should be able to round it to the nearest tenth. I got like 41.6. What's the answer there? So a good review problem involving trig, involving our quadrilaterals. So I feel like I blocked out this chapter when I was a kid in geometry, so just so you know, this is not something that's super logical, this chapter. It's formulas that, like I said, as a geometry student, like sophomore in, in high school, I don't remember learning this. I remember like when I had to learn it as a teacher, I feel like new thing that I had never heard before. So real quick here, area and perimeter of regular polygons. Now a regular polygon, just to remind you guys, regular polygon means all equal sides and all equal angles. So if the polygon is not regular, I can't use these formulas. So I'll show you an example of an irregular polygon. So when you guys draw like a little house here, I could not do this today with our formula. So this is not a regular polygon. So this rule today, so what a regular polygon is, all equal sides and all equal angles. So the formulas we're going to talk today only work for regular polygons. All equal sides and angles. So like a pentagon would be like this instead. I mean, obviously that's not perfect, but it won't look like your little house there that you would draw. So it has to be a regular polygon. So again, we're going to have a note card for this for the exam, which is going to be helpful because this formula is not the easiest formula in the world, and what everything stands for is not all that easy. So we're going to have to learn all these little different letters here. So the S stands for the side length. Now, the reason we only need to know the single S is because all the side lengths should be the same. So all of these should be S. So I could write S's around all of these. Make sure it doesn't look like a 5. N is the number of sides. So however many sides. That should be pretty easy. Either that's going to be given to you or you can count. In this case, it would be 6 sides. The capital P, the reason it's a capital letter is because it's actually a formula kind of all on its own. It's the perimeter of the polygon. So the distance around the polygon. Now, if I know the number of sides, and I know the side length, I can take the number of sides and multiply it by the side length. So the perimeter of that polygon can be n times s. That's it, bless you, that's that formula. So if you know the number of sides, you know the side length, you can just do n times s. This last one is a word that for years I think I said it wrong. And then I think I did Google, like, where it says a word for you, bless you. And it's apophthegm. Apophthegm.
How would you say it?
Apophthegm. And it sounded like I was saying a possum with a lisp. So my students thought that was always funny, and then I realized I'd been saying it wrong. Apophthegm. It's actually apophthegm, but it doesn't really matter. Except the person who figured out I was saying it wrong was like the know-it-all teacher across the hall, and then that was really annoying because she was right and I was wrong. So no one likes being told they're wrong by that person. So not Miss Moeller's, it was a teacher, Cedarburg. But anyhow, apophthegm, Cedarburg. So the apophthegm is the distance from the center of the shape to the side, and it's perpendicular to the side. And I'll show you guys what that looks like. So that's little a there, the apophthegm. So this formula, I have 2 different versions of the formula. There's 2 different ways to write it. One of them is 1/2. So this is the area, so capital A. 1/2 capital P, so the perimeter, times little a, so the apophthegm. And again, you're going to need to use a note card, so you don't have to stress about this. The other way to write it is to take perimeter out of there, because you have to figure that out. 1/2 little a, whoops, times n times s. So little a times the number of sides times the side length. Now, one of the things we need to know is something called the central angle. The central angle is going to help us if we don't know some of this information. So I'll show you guys what the central angle does on here. So the central angle, basically, it connects 2 of the vertices. We're going to call that x here. So the formula for the central angle is 360 divided by n. Lots of formulas for this one. Remember, n is the number of sides. And I'll show you guys why that's important. That's really only important for tougher problems. So, they asked for the central angle of a 10-sided figure. So here's our 10-sided figure. So what the central angle looks like is if I go at the center here, and I connect two of the vertices right next to each other. So they're looking for this angle here. Now if it's 10 sides, it's basically like I have 10 little central angles in there. So I'm taking 360 degrees, which is all the way around, and dividing it by 10. Which means that this little angle would be a 36-degree angle. Okay. So in number 2, they want us to find the area of this shape. Now we have to look at what we know. So when we find the area, I'm just going to use this one. We want to know A, we want to know N, we want to know S. I'm going to tell you guys, we're going to know 2 out of those 3, and we're going to have to find the third one. What do we know? A, N, or S?
A.
We know A. A is that apothem, and what that is the distance from the center to the edge, and it's perpendicular to that edge. So the A, the little a is 6.5. What else do we know? We know the number of sides. That's how many sides there are, so you can just count the number of sides. So this one has 5 sides. The issue is we don't know the side length. But hopefully you guys noticed that we should be able to figure out the side length because we have a little right triangle there. And if this little right triangle is here, I have this as like, well, maybe we just use extra over there. Let me call that y instead. We have that little y. Now, if I want to know the side length, I want to know this whole thing. So if I figure out y, what do I have to do with y? Multiply times 2, because this is also y. So in order to figure out s, I'm going to have to double y. How can I find y? Pythagorean theorem. So I'm going to do the Pythagorean theorem for this little right triangle here. So I'm setting up our Pythagorean theorem here using my 6.5 and 8. Oops, sorry, not equals yet. Now 6.5 is kind of an annoying one to do this squared for, because it's not just more decimals. And move that over by 64. Oops. And then I'm going to take the square root of that. And I find out y is about 4.66. Now, in order to figure out what s is, I have to double that, because each of those are 4.66. So I'm going to multiply it by 2. Now, I left that crazy decimal in my calculator and just multiplied that by 2, and I got 9.33. So I'm trying to be a little bit more accurate as I do this, that I try to maybe go more decimal places. Now I have enough to find my area. So I have to do a times n, or 1/2 a times n times s. find him on their iPhone? What have you stolen, Dakota? That you? No. I have.
Not me. I did not press the button. I saw a button and pressed
You just press buttons, you're like that kid.
it. She didn't only know she looked at me and I pressed it.
Oh boy. So our area is 151.6. Okay, so let's do one more and then we'll go outside. Let's go to number, let's go to number 2. Now I remember that I feel like I might have made these easier on the last year. I must have changed some of these up. So I'm gonna give you guys the side length this time. I'm gonna tell you S is 5.9. But remember, we need A, N, and S. Do I know A or N? I know N. N is the number of sides, so I just count my number of sides, so that's 5. Do we know A? No, that's not A. A, remember, is the distance from the center to the edge of the perpendicular distance. So we're going to have to do Pythagorean theorem again. This time we're looking for A. So I'm going to draw that little triangle over here. Now is this 5.9 over there? No, what do I have to do with it? You have to divide it by 2 because 5.9 is the whole side length. So I have to divide that by 2, cut it in half, and I end up with 2.95. So now we're going to do Pythagorean theorem. Why did we divide it in half? Because this whole thing was 5.9. This triangle we're talking about is only half of that. I know that's a strange step, but that's why you have to make sure we're visualizing that triangle. So we have A squared plus 2.95 squared equals 5 squared. Breaking stuff. A squared equals 16.2975. Going a few more decimal places because it's exact. And I got like 4.03, so 4.04, I guess. And then we're going to do our formula. And like I said, I leave a lot of stuff in my calculator. So this 4.0370, there's like a long decimal in my calculator. I just left it in my calculator so I don't have to retype it. Then I just multiply times 5.9 and then times 5 and then divide by 2 or times a half. And with 59.5. And it's probably a little bit more accurate answer if I leave those decimals in my calculator. All right, so we can take a break outside.